So, mastering hot upgrades on the BEAM. I think that the ability to do a hot upgrade, even in a production setup, is not just a very cool and rather unique feature of the BEAM, but I have a feeling that it's also sort of forgotten about as well. Just look at the tooling support. So every major build tool we have puts a lot of emphasis on simplifying the building of a release. That would be one particular version of your software in a ready-to-deploy package format. But what happens when we look at upgrading from one release to another? Reverse 3 categorically says that it doesn't want to deal with this problem. Use another tool. It says use RevFlow. The situation is a bit better on the Elixir side because Mix and Distillery at least offer you to generate some app-up skeletons. These app-up files are the upgrade instructions on which OTP's hot upgrade feature is based. But when it comes to developing the skeletons to a full-blown upgrade script, you're left on your own. And that's a pity because writing app-up files is not trivial. Even very simple projects, like the toy example used by learning some Erlang to introduce the concept of releases and upgrades. So even that simple project runs into 2 unforeseen upgrade issues, and then leaves them as an exercise for the user to solve. So I have the feeling that nobody actually wants to talk about writing app-ups. And just to set your expectations right, I won't talk about app-ups either. The reason for that is that my experience with hot upgrades comes from my work at Klarna, the CRED project in particular. And while we use hot upgrades from day one, we don't use OTP's tooling. We have our own custom upgrade script for performing this magic in production. But that's fine, because all the principles and best practices I would like to introduce, they work equally well regardless of the tooling of your choice. So let's begin. How do the BEAM does the hot upgrades? The documentation gives us a nice overview of the feature in just 3 short paragraphs, and we even get this example script. And I hope everybody is familiar with at least this much. Every module can have 2 versions of its code loaded at the same time, a new one and an old one. Whenever you do a fully qualified function call, you end up executing the new one. And if you do a local function call, you keep executing in whichever version you have been already. Nice and easy, but I think not all the implications are immediately obvious, so let's see some specific examples. In these examples, I will show old and new code side by side quite a lot. Old will be marked with blue, and green will be the mark of the new version. So in our case, we have this exterminate function that calls cat::hunt/2, and it has been written and tested together with the blue version of cat module. Now we want to deploy the green, new, modified version of our cat module. And it can happen that some process at the time of the upgrade is executing the exterminate function, so the blue exterminate may end up calling the green cat::hunt/2. So what could possibly go wrong with this call? The first thing that could go wrong is cat::hunt/2 doesn't even exist. Because, for example, you changed its arity or you refactored the code and moved it into a separate module. This is such a common issue that I would make it the first rule of thumb of hot upgrades. Do not ever remove an exported function that is still used by the old version of the code. Keep it around as deprecated for one more release, like this. The next thing that can go wrong is that the arguments you are calling the new version of cat::hunt no longer work. Most typically, you are passing some record and you change the arity of the record. Then none of the pattern matches will work in the new code on records coming from the old code. The standard solution for this is to add a clause to your function that will take the old format arguments and upgrade them to the new format one. But the other way around is also possible. So it can happen that the new version of cat::hunt returns a return value that the old code is not prepared to handle. And this is the more complicated situation because the old code is a given. We cannot change that. We only control what goes into the green version. Yet you have some possibilities. One of them would be to implement this extended version of cat::hunt under a new name. I've done this a couple of times. The biggest problem is that you usually don't have a better name, so you end up with things like cat::hunt_v2 or cat::newhunt. And then you have to spend one more release cycle fixing up this mess. The other thing you can do is you split your release into 2, and then deploy first a new version of the exterminate function that is already prepared to handle this retry response from cat:hunt, but only from the second release you actually start returning that value. If you are very ambitious, you can try to merge the two releases into one and just preload the new version of this pest module before loading the new version of the cat module. But if you do that, then this may not be feasible if you make other changes to pest, because then you may end up in a situation that the new version of pest calls into old version of other modules. And then you have to do a similar analysis on all of these calls. Move on to processes. Because hot code loading is atomic in a sense that all processes in the Beam get access to all newly loaded modules at the same instant, but they may not start using this new code at the very same time. So this example is a common pattern I see many times. We have a gen server that sometimes gets very heavy requests, and then it offloads them to a worker process. The worker process runs its custom message loop, and then the server remains responsive and can handle other requests until the worker is finished. Now, if we happen to load a new version of the code here in the middle of processing a request, it will not affect the currently ongoing request, because both the server and the worker only do local function calls by processing this request. Only at the end of the worker's message loop, you see that there is this fully qualified module loop call, and then it will upgrade to the new version of its loop. And the server will also get upgraded to its new code upon handling the next request, because of course the gen server module will do a fully qualified call to our callback module's handle call function. And then everything would work. But what happens if the code is loaded a little bit later, just after the worker started its next loop? Then it will still wait in its old version of the loop, but the server gets upgraded to the next version on the next request, and then it starts sending this new format message to the worker, which is not yet prepared to handle. You have a problem. So the moral of the story is that, similar to return values, message passing is a way for the new code to introduce incompatible data into the old code, which we have seen is the bigger problem than the other way around. And this example led us to my next chapter of the talk, the things where the Beam no longer covers or problems. Because these well-defined semantics of upgrading on the fully qualified function call are essential for building a robust upgrade solution. It only takes us so far. There are a lot of things that you have to solve on your own. Starting with handling the data in your processes. These are mostly the things that I've already covered, except for the funds in the bottom right corner. I want to call your attention to the thing that if you have a local fund, then it will be tied to the particular version of the module in which it was created. Meaning, first of all, you have a very good food gun for going back and executing old code an arbitrary time after the actual upgrade. And the second thing is, if you purge the old version of the code, then the fund will stop working. Either way, that's bad. So what you should remember, the rule of thumb is that you should always only keep fully qualified funds for an extended time. Local funds should be used and then discarded quickly. We also have a lot of state in our system. First, in the application level. I won't have time, unfortunately, to go through all of these. I tried to put some API calls as pointers on the slide so you can read them later. But basically, what you should think about is if you change like the supervision tree of your application, and the new version requires 2 more gen servers to be present, those servers won't get magically started just by your existing processes upgrading to their new code via a fully qualified function call. You have to write your upgrade code on your own and specifically start those. The same goes to state on the system level, like set of applications running or application environment settings. And you shouldn't forget about the external dependencies. If you require a new version of your database for the new version of your software to work, you have to synchronize the upgrade of these 2 systems on your own. Right. Another kind of problem that is what can happen with changes in processing pipelines, and I think this is best explained via an example being a REST handler for Cowboy. So a Cowboy REST handler is a module that implements a bunch of optional callbacks, and Cowboy follows this flowchart and calls these callbacks until it figures out what response to send to the caller. And in our example, we want to sometimes send 307 move temporarily responses. So we had to implement here the resource exists, previously existed, and move temporarily callbacks. We didn't have to implement move permanently because we can just go with the default value of false. But now we want to go to a new version of our software, and we decided that we want to respond with 301 move permanently instead. The natural way of solving it would be to rename move temporarily to move permanently, right? The problem is that this is not upgrade safe, because imagine we already have a request in progress that has just passed the move permanently check when the upgrade happens. So Cowboy now called a new version of our REST callback when it wants to check whether it's moved temporarily. We no longer have this callback, so we will go with the default route and send a 410 gone response to the client. Oops, not what we wanted. The moral of the story here is that if we have this processing pipeline and we have some check or processing step that we move to an earlier stage in the pipeline, then we risk this not happening at all during a hot upgrade. On the other hand, if you move something to a later stage, then the risk is that this will be executed twice for the same request. This is not a particularly common error. I can recall exactly one instance during my 9 years at Klarna when we run into this problem, but it can happen during plausible refactoring, so I wanted to mention it. The other thing I definitely wanted to mention is the Swiss Army knife of hot upgrades, the sys module. Because sometimes you cannot just write all your code to be backward compatible. And then your only option of making things safe is to avoid doing the problematic thing at the problematic time. And if that problematic thing happens to be initiated by a gen something process, then you are in luck because you can use sys-suspend to just suspend this process for the time of the upgrade until you sys-resume it. While suspended, the process will not do its regular task. It will only listen for system messages coming from the sys module. But that's not all. We also have the sys-replace state function. It's designed to take a fun that is executed in the gen server process and can transform its state, similar to what you can do with the code change callback. But it's much more. It's a way for you to do an arbitrary function and execute it in an arbitrary process. You can do magics with it. You can, for example, set up monitors and links that you can only do from inside the process. Or you can go through the message queue of the process and discard all messages that the new version is no longer meant to deal with, and these kind of things. I very often use sys-replace state only for these side effects without actually changing the state of the server. So it's a very good tool to know. Okay, so far we have seen that during a hot upgrade, we can run into various issues that we have to solve and work around by writing upgrade code. These will be our building blocks. Now we'd like to switch views and look top-down on the process and see how to build from these building blocks a robust process that will guarantee safe upgrades for us. What I cannot stress enough is if you plan to do hot upgrades, you always have to keep that in mind when you are coding. Whenever you change anything, any data structure, any internal API or external API, always ask yourself, is it going to be backward compatible? Can my new code handle data coming from the old code? And if not, or if you change anything in the state of your application or system, you have to write this upgrade code. And you have to write this upgrade code continuously along with the features. My advice is that if you want to delay this and first implement the new version of your system and then only then figure out what should go into the upgrade files, don't think that would work. The reason for that is that all these upgrade issues come from very tiny changes in the code. And when you look at the big diff that contains several features, a dozen of bug fixes, and God knows what else, then it's very hard to understand the implication of every single line you see in the diff. It's much easier if you are looking at a small diff. So my advice would be to utilize code reviews for that. Because then you're already looking at a diff, you are looking at the smallest meaningful diff, nevertheless. So take that time to spot upgrade issues and try to fix them and also review your upgrade code. And then at the end, when you are making when you're about to cut a new release, you still have to do one more final check and see that all the upgrade code that you wrote for the different features still work together. There are no issues between them, but that's a manageable task. Next thing is to test your upgrades. And the problem is that these upgrade issues are typically race conditions. They only happen if your system is happening to do the wrong thing at the exact time of the upgrade. So it's not enough to test it on an idle system. You want to do it under load, preferably a lot of load. And the ideal scenario is if you already have a load test and you can repurpose it to also work as an upgrade test. Alternatively, you can try to run this test repeatedly, but then remember that you have to investigate every single error. Even if something failed only once out of a dozen test runs, well, maybe that was your only chance to catch that particular race condition. But ensuring that the upgrade doesn't crash is only half of the problem. The other half would be to make sure that the upgraded system is identical to a fresh installation of a new version of the system, which is unfortunately a problem that you cannot really do test in a generic sense, because you are not really dealing with fresh installations, but fresh installation plus some random traffic changing the state, and then the change is not bit by bit comparable, because it will contain irrelevant differences like timestamp, UIDs, and whatnot. But what you can do is to at least verify some key properties of the system. One very useful key property to verify is whether the upgraded system can be restarted. It sounds awfully trivial, but I've actually seen many cases when the upgrade went fine, but the resulting system couldn't be restarted, typically because some upgrade code changed the runtime state of the system, but forgot to persist the changes to disk or some database. Okay. Then, no matter how much you test, you need to prepare for problems during the actual upgrade in production. You can't avoid that. But two things come handy when you face this. One is if all your upgrade code is idempotent. Because remember, these were race conditions. If you try them again, then there's a good chance that the race condition will simply not materialize. But you can only safely try again if your code is idempotent. The other thing is that you need to know the inside out of your upgrade script. So if your upgrade fails and the retry fails again, you can at least jump into the shell and try to bring your system to a working state manually. Okay? By the way, do you know what is the best way to avoid errors during hot upgrade? Is to not do any hot upgrades at all, which is only half a joke. What I really want to say is that you should try to reduce the attack surface for these race conditions. Because you can probably have a lot of non-critical parts of your system that you can simply stop. You don't have to run Kafka consumers, batch processing tasks, cron-like scheduled things. They can safely be stopped for the couple of seconds that it takes to upgrade to the new version. The other thing is to limit the blast radius of errors. So you can try to harden the critical parts of your system by increasing the restart limits in supervisors and increasing the timeout of your various Django calls. And that's all. This gives us a recipe for putting together this masterful upgrade script. It starts with the pre-upgrade phase, where we first add things that only exist in the new version of the system and not in the old, like load new modules, start new applications, create new ETS tables. The old code doesn't know about this, so they are usually safe to just be created. They will just sit there idle until somebody will try to call them and use them. Then you can go and harden the critical parts and stop the non-critical parts before moving on to the actual upgrade phase, and you run this carefully tested upgrade code. And then comes the post-upgrade phase, when in reverse order, you restart the parts that you stopped, undo the hardening, and then remove everything that no longer exists in the new system, including purging the old modules. But this last thing is only safe to do once no processes are left executing the old version of the code, which means you have to wait a little. But how much exactly? Well, in case of CRUD, we have some functions that can run for hours, literally, without a chance of upgrading, because they do something like yearly report calculations and whatnot. So you cannot just put here a hard-coded timeout. The correct solution is to try in a loop and soft purge until all the reloaded modules until you succeed. Or you can do another trick and say that keeping around this old code is not a big thing, it's just some memory wasted. So let's delete as much as possible. We can delay it just before the next upgrade. So we will get this updated masterful script, which is almost the same thing that we actually do with CRED. In the middle part, the upgrade is a bit better structured in our case. You can write custom before upgrade code, and then we have a standard step where we load all modified modules, and then you can have some custom after upgrade instructions, which is a more constraint than doing whatever you want, but this model was enough for us so far. Okay, last chapter. When to use hot upgrades? To answer this question, we have to see what would be the alternative, what are cold upgrades. These are upgrades when we upgrade the system by not taking traffic. This is what the rest of the world outside of the BEAM community has to live with. And they came up with some very nice strategies like rolling upgrades or blue-green deployments, which have a bunch of tremendous benefits. First of all, good tooling support. You can use Kubernetes or Terraform to automate these upgrades. And the good thing is that these tools treat your system as a black box that can be stopped, started, and maybe a new version installed. But it means that you can just take everybody else's upgrade script and use it for your own system. You don't have to come up with your own upgrade script. You don't have to even write upgrade code that could cause all those issues because the system is stopped or not taking traffic for the time of the upgrade. But the best thing is that this model applies to all layers of your test stack. Because no matter how good you are in hot upgrading your OTP application, time will come that you want to upgrade your ERTS, or do some OS patching, or move to a new hardware. And then what? You don't have any other option then just to do cold upgrades. But then, if you cannot avoid doing cold upgrades, and you have very good tooling support for them, then is there any reason left for doing do-it-yourself hot upgrades? I think there are, but mostly in some niche scenarios. If you have a large system that you deploy in the cloud, large being that you have to keep your infrastructure as a code, then just go with Terraform and do blue-green deployments. That's actually what we would like to do with CRED as well, because we already have to use Terraform, and we would like to be on the same platform than the rest of the company, because that also has a lot of benefits. But not all systems are deployed in the cloud. If you are in a hardware-constrained environment, like in your own DC, or God forbid you are in an embedded scenario, then it can be a big benefit that you can do in-place upgrades without downtime. Also, if you may have a small system, and so far I was talking about the problems and difficulties of doing hot upgrades, but it's not necessarily like that. Doing a simple hot upgrades setup for your system may be easier than learning a complex orchestration tool like Kubernetes. So in that case, I would advise you to do your cost analysis, because this can, most of the time, work easily. Like in case of CRED, most of the upgrades don't contain any custom upgrade code. Just the standard part of the upgrade pipeline can handle those things. And even if you have to write something, then it's just a few lines of code. So that's not that bad. The other thing is, if you don't have to treat your system as a black box, but can treat it as a white box and look into it during the upgrade process, then you can fine-tune your upgrade for specific needs. You can do things like synchronize your entire cluster at particular points, or decide to minimize the time when there are two versions of your application running side by side and accessing the database, which is not without risk, of course. This kind of things. So I had this much time, so just to reiterate the takeaways, you can get very far in hot upgrades just by following a few simple rules of thumb, like always code with hot upgrades in the mind, do not tie yourself accidentally to one particular version of your code, always keep exported functions around one more release as deprecated, and be prepared for errors happening in production. That's it. Thank you.
Thank you, Daniel. I think we'll all go home and tweak our upgrade code. Okay, do we have any questions?
Hello, I'm interested to understand what your plan B is, or when the upgrade goes wrong, what's your recovery from that, and also how do you trust the BEAM file you're loading that it's really your file and not somebody else's file that someone managed to sneak in?
So how to recover manually from a failed upgrade? Well, this is the part when you have to know what your system and see the logs and decide, oh, I know this is where the bug is and I know how to work it around. There is no good recipe for that other than be creative and know what you are dealing with. And I didn't understand really the second one. What component trustworthiness are you asking about?
If someone has snuck in an unknown BEAM file.
Okay, well, that's, to be honest, I would keep it as a separate issue. I mean, like, if you have a release and you should build it in a trustworthy environment, and then you can do things like, I don't know, code signing or signatures on the package to verify that it's trusted. But once it's deployed on your machine, I mean, if somebody has the capabilities to go there and put their additional files, then you are probably already screwed a bit.
Okay, do we have time for more questions if there are any?
Thank you. You mentioned some costs of doing hot code upgrades, like
yes.
Like some direct costs, but also like the indirect cost of always keep this in mind when writing code, and every team that works on the system needs to keep this in mind when reviewing code. So how much faster would you be without hot code upgrades?
So it really depends on the kind of changes you make. I would say that most of the changes that come from business needs. In case of Klarna, it can be something like, oh, let's go and add support for one more market. Then these don't change the architecture of your software. It just let's extend some lookup tables with 2 more entries so you know what is the currency in Switzerland or whatever. These will not cause upgrade issues, typically. So they are safe. Or fixing bugs in like how do you calculate some formulas or whatever. These are easy to deploy and don't require a lot of thinking. Maybe what I mentioned that you shouldn't, when you do some refactorings, then keep around the old code as deprecated, or the old exported function as deprecated for one more release, and that's all. But when you want to do big architectural changes, then yes, it can be a lot of issues. Like when we were doing the migration from niel to Postgres, it would have been easier a lot of time to say, okay, we just shut down the entire system and then start clean on the new state. But if you have to keep database replication flowing and happening between the nodes while they are updating, then then it's a hard thing, and then you have to think a lot about how to do that. I don't want to give an estimate on how much faster we could have done it without hot upgrades. The other thing is if you do it with hot upgrades, then you do it in small steps, which means that it's also more secure, and that has some benefit in case of big refactoring. So that's on the other side of the scale.
Thank you. We have time for one more question. I have one over here.
Thanks. So you mentioned that basically testing code upgrades and the tooling you mentioned also. How should the tooling be improved to make this a more seamless story? Kind of like libraries for maybe simplifying automated testing of hot code upgrades in a generic way, better tooling to analyze the code. What would be in an ideal world?
So it depends on a lot, I think, on how your upgrade, so how the new version is packaged. Like in case of if you're using OTPs, releases and OTPs upgrade mechanisms, then you can, that's a pretty much well-known standard, so you can automate this for all the systems that use that. If you would deploy like a new RPM or some other packaging mechanism, then that could be also automated. That would cover all those systems. But that's only the part when we are talking about deploying the upgrade, and then you have to add on top of that things like generating load that will be very specific to the system you want to test. So you have to first deploy the old version, start some load generator, then use this part that can be made more or less system independent to deploy the new version. And then you also have to verify that things went fine. And that would be probably skimming through logs. Or also, once again, it also depends on your system. In case of CRED, it's quite easy to tell because we explicitly write upgrade logs into a specific log stream, so you can just look for errors in those, and then of course you have the basic sanity checks that the system is up, it's not consuming too much memory, it's not consuming too much CPU, requests are going through, no spike of timeouts or no spike of crashes, but it's still, it is a bit of a manual process. I think you may be able to automate it, but we haven't so far. And it worked well enough that an automated system builds a report, collects together all the bits of information, and then a human user looks at it and says, okay, these graphs looks okay to me. I mean, maybe you can train an AI nowadays to do that for you, but before that I don't have an idea how to do it better.
All right, thank you so much.
Thanks.
And that's it for this morning session.